In this video, we're going to focus on word problems that involve right triangles and the Pythagorean theorem.
Let's say we have a right triangle whose sides are A and B, and the longest side or the hypotenuse is C. The Pythagorean theorem states that the square of the longest side or the square of the hypotenuse is equal to the sum of the squares of the other two sides. Now let's solve some problems.
Number 1. The foot of a ladder is 10 feet from the wall. The ladder is 2 feet longer than the height that it reaches on the wall. What is the length of the ladder? Let us say this is the wall, this is the ground, and the ladder is resting against the wall. Where the foot of the ladder is 10 feet from the wall, and then according to the problem, the ladder or the length of the ladder is 2 feet longer than the height that it reaches the wall. So let's call this height h, and the length of the ladder is 2 feet longer than the height, so that would be h plus 2. We are asked to find the length of the ladder, and that is h plus 2. To solve for h plus 2, our working equation is the Pythagorean theorem, which states that the measure or the length of the longest side, in this case h plus 2 squared, is equal to the sum of the squares of the other two sides. So we have h squared plus 10 squared. Let's expand the left side of the equation. This is equivalent to h squared plus 4h plus 4 equals h squared plus 10 squared is 100. Combining like terms, we can cancel out h squared so that we are left with 4h equal to 96. Divide both sides by 4, so h is equal to 96 divided by 4. That would be 24 feet. And since we are asked to find h plus 2, or the length of the ladder, is equal to 26 feet. Next problem. A pencil box in the shape of a rectangular prism measures 16 centimeters by 12 centimeters by 8 centimeters. Find the length of the longest pencil that would fit inside the box. Let's say this is our pencil box with dimensions of 16 centimeters by 12 centimeters by 8 centimeters. Now, the length of the longest pencil that would fit inside the box is equal to the length of the longest diagonal of the rectangular prism. So from this point, for example, to this point, this is the longest diagonal. Let's call that x, and so the required is x. So for 3D figures, we just add another dimension to the Pythagorean theorem. The square of the longest diagonal is equal to the sum of the squares of the dimensions of the rectangular prism. So we have 16 squared plus 12 squared plus 8 squared. Solving for x, we get square root of 16 squared plus 12 squared plus 8 squared, which is equal to 21.54 centimeters. A circular cylinder is circumscribed about a rectangular prism having a square base of 1 meter on an edge. The volume of the cylinder is 8 cubic meters. Find its altitude in meters. The cylinder is drawn around the rectangular prism with the edges of the rectangular prism just touching the lateral surface of the cylinder. The base of the rectangular prism is a square base with 1 meter each on an edge, and then we also have the volume of the cylinder, which is equal to 8 cubic meters. We are asked to find the altitude or the height. Let's call the height h. To solve for h, we can start by using the formula for the volume of the cylinder, because the volume is known to be 8 meters cubed. So volume of a cylinder is equal to pi radius squared times height. Okay, so we can plug in the known values. For the cylinder, volume is 8 cubic meters, equal to pi. The radius, however, is unknown, so r squared, and of course the height is also unknown. So before we can solve for h, we first have to solve for the radius. So to solve for the radius of the cylinder, let's look at the square base of the rectangular prism. We can draw a line from the center to the vertex of the rectangular prism touching the circular base. This one. This represents the radius of the cylinder. Let's focus on the square base of the rectangular prism. So let's say this is the square base. From the center to this corner, this is the radius of the cylinder, right? And then each edge of the square base is 1 meter. Okay. If this line is equal to r, the opposite side is also equal to r. Therefore, in total, this diagonal is 2r, right? And then we have a right triangle. So we can apply the Pythagorean theorem. The square of the longest side is equal to the sum of the squares of the other two sides. So each edge is 1 meter. So 1 squared plus 1 squared. So we have 2r equal to the square root of 2 if we take the square root of both sides. Therefore, r is equal to square root of 2 over 2 meters. So let's plug in this value to this equation. equal to pi r squared, where r is square root of 2 over 2 squared times the unknown height. Solving for the height, we get 16 over pi, or that's approximately 5.09 meters, or just 5.1 meters.